In this section, we're talking exponential and logarithmic equations. The goal is to solve these things, so let's do it. The properties that are going to come in handy in this section. Number one, a to the x equals a to the y if and only if, that's what IFF means, if and only if the exponents are equal. Well, okay, a better not equal 0, or a better be greater than 0 and not equal to 1. But as long as that's satisfied, property 1 is going to hold. So that's going to be a useful property for some of the equations we saw. Also, number 2, log base a of a to the x is equal to x. We've seen that. And then this one, it has a name actually. It's called the one-to-one property of logarithms. It says that if the log base a of x equals the log base a of y, what has to be true? The inputs are equal, right? And it works both ways. So if x equals y, look, this is really important. If x equals y, it's almost like you can take the log of both sides of this equation. It's not multiplication though, is it? That's what, and students mistakenly think that when they first see it. But it's like you can insert both sides, x and y, into the log base a function. Well, I mean, that should be true, right? If x equals y, if the inputs are equal, the outputs of a function will be equal. So going from right to left, it's, well, I mean, it has to be true, right? If the inputs are equal, the outputs are equal. Going, that's right to left. Going left to right says, oh, if the outputs are equal, so the outputs are, this is like f of x, this is like f of y. If the outputs are equal, then the inputs are equal. That's not true for all functions, but for one-to-one functions, it's true. Okay, so keep those 3 properties in mind. I'll refer to them when we need them. In this example, we're going to solve exponential equations. I claim you already know how to solve 4 to the 3x equals 32. What does this first property tell us that maybe we'd like to have if possible? Wouldn't it be nice to have the bases of the exponents the same on both sides? Then couldn't we just set the exponents equal? Yeah, we actually saw that idea back when we talked about logarithms and exponential functions for the very first time, a couple sections ago. So 4 to the 3x, 32, so we have a base 4, we have 4, and then we have on one side, and then 32 on the other, right? I can't write 4 to some power equals 32. That's not going to work. But is there a base that will work? 2. So here's the idea, you guys. I could write 4 as 2 squared, which means on the left-hand side we have 2 squared to the 3x. And then on the right-hand side, is 32 a power of 2? 2 to the 5th, yeah. And then what's the law of exponents say that I do with the 2 and the 3x? Exponent on the inside, exponent on the outside, you multiply, so you keep the base 2, and you multiply this 2 times the 3x and get 6x, right? So 2 to the 6x equals 2 to the 5th. What do you do at this point? You got like bases, so set the exponents equal, right? 6x is equal to 5, or x equals 5, 6. Do you think you can check your answers? Yeah, just on your in your calculator, go 4 to the 3 times 5, 6, and you'll get 32.